Hello guys! Welcome back for another video lesson. So just in case you were wondering anong mas nauna na ko og-upload ang week 2 nga lesson, it's because giuna na ko siya og record. Okay, if you could remember na I wasn't able to do the lecture during your sync classes. So what I did is nag-record ko og video and then gi-upload na ko siya una. So I thought ipaulahin na lang sana ko ang week 1 o week 3. It's because manam ko na. So here is it. This is the week 1 lesson. So for this specific video lecture, we are going to learn about kinetic molecular model of liquids and solids. So these are the target objectives that we would like to achieve at the end of this lesson. No? So at the end of this lesson, you would be able to use the kinetic molecular model to explain properties of liquids and solids, describe and differentiate the types of intermolecular forces of attraction, and predict intermolecular forces present in a molecule. So there are actually two main parts of this lesson. The first one, we will be learning about the kinetic molecular model, and then the second one, of course, are the different types of intermolecular forces of attraction. So I hope you have your lesson packets with you. You have your pens and notes so that you can take down notes. No? So before I proceed, let me just talk briefly about phase changes. Why will we be talking about phase changes? It's because it will be an integral part of the lesson. Okay? We will be talking about manggod, solids, liquids, and gases, the differences between the particles of each state of matter. So if you could remember your junior high lesson, or actually sa elementary pa man siguro ni na-discuss sa inyo, di ba? If you could remember, you would know why solids behave different. You would know why solids behave differently compared mo sa liquids, and you would also know why liquids behave differently compared mo sa gases, and vice versa. So now, why are we talking about phase changes? It's because these different states of matter, see solid, liquid, and gas, they could be converted into different forms. For example, converted or transformed rather. So solids can be transformed to liquids. And then we have liquids that can be transformed to gas and vice versa. Diba? So ang tawag nga transformation, we call them phase changes. So it's directly influenced, or it's heavily influenced by changes in physical conditions, most specifically by temperature and pressure. So, naay instances na if naay changes sa temperature or pressure, for example, if i-increase mo ang temperature in a particular environment, some solids can be converted into liquids. Or, imong i-manipulate ang pressure in a particular environment, some liquids can be converted into solids. Okay, so vice versa. Now, phase changes are always accompanied with energy change. So, as you can see in the picture, no, on the right side of the slide, you can see ka ng mga diagrams here. This is what we call a phase diagram. It basically illustrates the changes in the phase of a matter under varying temperature and pressure conditions. Now, we won't really be dwelling in this in details. Kaya I separate na module for this. So, I think it will be on module 4 that we will be kanang digging deep into the details about phase diagrams. So kato lang, I just want you to remember that there are phase changes that involve in different states of matter. So let's continue with the focus of the lesson again. So the first part of the lesson, we'll be learning about the kinetic molecular model. So what is kinetic molecular model all about? It's basically an underlying principle that explains the properties of liquid and solid molecules, actually even gas molecules, but in this lesson we will be focusing on liquids and solids muna. So as well as the forces of attraction that account for such properties. Now, as I have mentioned before, no, if you could remember, no, nga kanang ang particles sa mga solids kay lahi ang ilang behavior sa mga particles sa liquids and gases. And because lahi-lahi ang behavior or ang interaction within these particles, gavary pod ang forces of attraction that bind these particles. So this is basically explained by the kinetic molecular model. So since these particles are constantly moving, of course, there is an energy involved. Okay, that's what we call kinetic energy. So kinetic energy is defined as the energy needed to keep the particles moving, which is dependent upon temperature. Generally, class, if na ay mga changes sa temperature, for example, if the temperature is too high in a particular condition, of course, lahi ang behavior sa mga molecules or sa mga particles, regardless if solid or liquid na siya. If ubusan po ng temperature, lahi po ang behavior ani nga mga particles. Okay, so remember, kinetic from the Greek word kinein, it means to move. Now, these are the three postulates that basically explain why the particles of each phase of matter are the way they are. Okay, so this is basically the postulates of the kinetic molecular model. So the first one is about solids. So, ang ilang mga particles daw, they are closely packed together. Okay, they are densely packed together. Pasabutan na, they are very bound close to each other. They are very bound. They are bound very close to each other. So, because of their compact arrangement, solids have definite sizes and shapes. Diba? When you look around your surroundings, if you could see a solid, you might be able to kanang realize nga, no, you might be able to realize no nga why do solids come in different sizes and shapes and volumes. It's because of the close packing of their particles. So because of this kanang because of these particles po, because of the arrangement of these particles, these allow solids to have different properties like malleability, ductility, hardness. I-compare nimo sa mga liquids and gases. So we'll be talking about malleability, ductility, and hardness specifically no, or in details when we reach solids na lesson. So I think that will be on week 3 nga lesson, or week that will be on the week 3 nga video lesson. So the second postulate kay it's about the liquids or about liquids. So ang ilan ng particles i-compare nimo sa mga solids are slightly far from one another. So because of this class, liquids have no definite sizes and definite shapes. So kasalig lang sila sa shape o size sa ilang mga containers. For example, if magkuha ko kanang container nga cylindrical ang iyang shape, if magbutang ko og tubig, of course, ang makita nimo nga shape sa tubig kay cylindrical because again, it follows or it takes the shape of its container. No? Though slightly far from one another ang particles sa mga liquids, liquids are still tangible. Okay, we can touch them. But again, because of the space between these particles, it allows liquids to flow. Now, ang ability of liquids or kanang the resistance of liquids to flow, differ po na siya. Okay? That's viscosity. We will be talking that, we will be kanang learning more about it on week 2 nga video lesson. So, of course, the last postulate is about gases. So, if ma-compare nimo from solids and liquids, gases, ang particles daw sa gases, they move freely and are very, very distant, are very distant from one another, which is why we cannot see gases, diba? We cannot see the particles of gases, of course. So, furthermore, gases diffuse easily. Okay? So, if you can see the picture on the right side of this slide, you can see the different states of matter. We have solid, liquid, and gas, and then the different processes involved during these phase changes. Okay, so if you have a solid and then you want to convert it into liquid, or if you have a solid and it's being transformed into its liquid state, ang tawagan ng process is melting. And then if we have a liquid and then it will be transformed to its gaseous nga phase or state, that's called vaporization. So if you have a gas and then it's being transformed to its liquid state, ang tawagan ng process is condensation. And then if you have a liquid and then you want to transform it into its solid phase, ang tawagan ng process kay freezing. Now, if you have a solid and it's being converted to its gaseous phase without passing through the liquid state, ang tawag ana kay sublimation. Of course, the opposite, actually we call it reverse sublimation, is when a gas is being converted to a solid without passing through the liquid state. We call that deposition. Okay, so these are You might be familiar with the other processes, no? Melting, vaporization, condensation. Okay, I think nanani siya sa kuan in mga previous nga lessons, previous chemistry or science lessons. But you might not really be familiar about sublimation and deposition. So, examples of sublimation are mothballs. Examples of sublimation, or an example of a sublimation process kay kuan kaning mga mothballs nga kanang kuan kanang gagamiton bitaw to they serve as kanang chemical pesticides and also used in deodorants. They are mostly contained they mostly contain naphthalene, no? I think ang mga kinaraan nga mothballs kay naphthalene ang iyang major composition, pero ang mga bago na nga mothballs kay gi-change na, dili na siya naphthalene. I think it's dichlorobenzene. I think gi-change na siya because naphthalene is actually flammable. So, sublimation, it's the conversion of a solid to its gaseous state without passing through the liquid state. So if makabantay mo na if magbutang og moth, usually sa mga cabinets man na ginabutang no kay to it's a pesticide para dili ukukon ang mga sanina or inyong mga gamit. So if you could notice after pila ka hours or pila ka days kaka-hiyos siya, kagamay ang iyang size because again it's being exposed to air. Diba? So another example of sublimation is dry ice. Dry ice is actually the solid form of carbon dioxide. So it's usually used as kanang mga visual effects sa mga theatrical or movie performances. Karamihan mga nakakita ninyo mga pausok-usok effect. So that's actually dry ice. So if you can see in the picture, this is dry ice and then this is its gaseous phase. So, if you could notice na wala kayo makita nga moisture, kaya again, dili naman siya muagi og liquid na state niya. Okay, so that's sublimation. And we have deposition here. It's the reverse snow process. It's when a gas is being converted into a solid. So, one very common example is kana formation of frost in leaves or kana sa mga twigs and mga branches during cold winter days. We cannot really relate to this kay wala mamutay winter season dali sa Pilipinas, but in areas nga experience winter season, so it's usually when winter air deposits are being kanang exposed directly into a solid, thus allowing the formation of crystals. For example, sa mga bintana, kanang sa mga walls, di ba? So, aside from that, kato lagi sa mga leaves and mga branches. So that's deposition. Now, let's proceed to the second part of this video lesson. So we will be learning about the intermolecular forces of attraction. So, shortcut na ko siya into IMFA ha. So, when you encounter this kind of acronym, it means intermolecular forces of attraction. So, these are forces that hold or bind individual particles such as atoms, molecules, or ions together. So please remember the differences between molecules, ions, and atoms. Ha? So basic na siya. Now, there are intermolecular forces that are too strong na po'y mga IMFAs nga mga weak ra kaayo. Okay? So the reason why differ ang ilang strength is because of these three reasons. So the first one is the arrangement of the particles. The second one is the proximity or the closeness of the particles relative to one another. And then of course the third one is the nature of. So when you talk about the arrangement of the particles, no, naman may mga molecules class na because of the arrangement of the subatomic particles, for example, ang mga electrons, naman may part sa molecule na mas kusog ang kibali or mas partially negative nga part ani nga molecule na po'y part sa molecule nga mas partially positive siya. So because of this kanang arrangement, it actually allows the molecule to be attracted or it allows the molecule to be more likely attracted to other particles. No? So mo na siya. For example, water molecule H2O, no? So okay, this molecule right here, this is actually water. So kaning red nga circle, let me just change the color. So kaning red nga circle, this is actually the oxygen, and then kaning white circles, these are the hydrogen molecules. So, ang oxygen atom, it's where the lone electron pair is actually located, making it partially negative. And then, ang hydrogen atoms makes it partially positive. Okay? So, because of this kanang arrangement, of course, ang oxygen molecule is more attracted to the partially positive portion of another molecule. And then the partially positive portion of this molecule is more attracted to the negative portion of another molecule. Okay, so that's because again of the arrangement of the particles. Now, the second one is the proximity of particles relative to one another. Kibali ang closeness or ang kalayo sa mga particles from each other. So, naay bonds class or naay mga instances na if mas layo ang particles from one another, the weaker ang intermolecular forces of attraction. So, naay mga instances na if mas duol ang molecule to each other, if mas duol ang particle sa isa ka molecule to each other, mas strong ang intermolecular forces of attraction. And of course, the last one is the nature of the interacting particles. So, one of the differences or one of the main reasons why galahi-lahi ang strength sa IMFAs, it's because lahi-lahi ang mga atoms class, di ba? If you could remember in the periodic table of elements, the atoms or the elements are classified accordingly. Natin magipang tawag na metals, natin magipang tawag na non-metals, natin magipang tawag na mga metalloids, na yung mga kato mga elements that are under the lanthanide series, na po yung mga elements na gipagtawag na ito nga halogen or noble gases. So, nasa sila mga kinaiya or mga characteristics na wala sa mga uban elements. So, because of their own nature, no, if they are being partnered with other molecule or other particle, of course, it influences the strength of the intermolecular forces of attraction. The intermolecular forces of attraction influence the resulting properties of solids, liquids, and gases, such as boiling point, viscosity, vapor pressure, and heat of vaporization. So if you could remember, no, we just discussed the differences between the particle arrangement or the behavior of the particles between solids, liquids, and gases. So because of this behavior, no, it's also the reason why liquids have properties na wala sa solids, and why solids have properties na wala sa liquids, and why gases have properties na wala sa liquids and solids. It's because of the intermolecular forces of attraction that act between these particles. It's also the reason why solids and liquids and gases have different boiling points, viscosity, vapor pressure, and heat of vaporization. So basically, mga properties. These are examples of properties. So I want you to remember this, okay? The stronger the intermolecular forces of attraction, the greater is the required amount of energy to break off or to overcome these forces. So if weaker ang intermolecular forces of attraction, which makes sense, no? Kay mas dali pod siya ma-break off. So it means you will need or you will require less amount of energy to overcome these forces. So the IMFAs are also responsible for the interactions within a molecule, such as covalent and ionic bonds. Now, so let's proceed to the four main types of intermolecular forces of attraction. In some references, they also call it as van der Waals forces. So it's actually pioneered by a Dutch scientist, that's Joe. I'm not really sure how to pronounce his name, mabasa muna na ang iyang spelling. So there are four types of intermolecular forces of attraction. The first one, we call it the London Dispersion Force, or LDF. And then we have the Dipole-Dipole Interaction, we have IronDipole Interaction, and we have the hydrogen bond. So let's proceed with the first one, the London Dispersion Force, or LDF. It's named after the German-born physicist Fritz London. So among the four, no, it's actually the weakest among the intermolecular forces. So I want you to remember this. If makadungog LDF or London Dispersion Force, it's actually a result of the process called polarization. So what is polarization? It's defined here as a distortion of the electron cloud brought about by the presence of a highly charged particle. So namo may mga instances class nga ang arrangement sa electrons in a particular atom ay ga-change. Okay? So, naay part sa atom nga mas electronegative siya or mas dito gatapok ang mga electrons, na part sa atom nga mas gamay siya og electron. Okay? Ang tawagan na nga process is polarization. So the number of electrons in an atom affects the polarizability of the atom. So remember this, the larger the electron cloud or pasabot na mas daghan ang electrons ana nga part sa atom, the higher the chances of the atom getting attracted by a positively charged particle. Okay, remember, in the rules of chemistry, opposites attract. Okay? A positively charged particle will always be attracted to a negatively charged particle, vice versa. Dili pwede ang same signs, or if they are of the same same signs, they repel. Okay? So again, opposites attract. So, because of this polarization, natay form or natay purma nga gitawag nato nga temporary dipoles. So, these are originally atoms, but again, because of the distortion of the electron cloud caused by polarization, gakahimo sila nga temporary dipoles. So, what is a temporary dipole? One end of an atom is partially positive and the other end is partially negative. Okay, let me try to illustrate it to you, through this picture. I actually got this kind of illustration from a video. It's from Khan Academy. I highly suggest you watch their videos. Kinais kayo ang pagka-explanation. So I'm actually a fan. So anyway, now, for example, this is an atom here. If you could remember, diba, ang structure of an atom kay in its kanang dense core is the nucleus, which is technically positive. Kinamanggot inside sa nucleus ang protons and neutrons. And take note, protons are positively charged. Surrounding the nucleus are the negatively charged particles. We have the electrons. Okay? So now, through the process of polarization, katong gi-mention ako ganina na ay instances na ang electron sa isa ka atom kay will be concentrated on one end or on one region. Okay? So, causing one region to be more electronegative or partially negative. Okay? So, nakakita ninyo mas dagan ka ng electrons that is sa right side i-compare nimo sa sa left side i-compare nimo sa right side, no? So, through the process of polarization, we have this what we call a dipole. Okay. Now, ang atong dipole class, na siya partially negative, na siya partially positive nga regions. So, if this dipole is if it's just existing and then it happens na siya makita nga another nga atom, this atom will also be formed into an induced nga dipole. So, pareha na sila. Natay dipole and then natay induced nga dipole. So, this induced dipole, kinapo siya partially negative nga region, napo siya partially positive nga region. So, the force that bind these kanang regions together, this is what we call the LDF or the London dispersion force. Okay? Take note, the partially positive of an atom is attracted to the partially negative of another atom. Okay? So that's London dispersion force. Specifically lang sa LDF kay if it's a dipole and then another if it's a dipole to an induced dipole. That's why in some references, LDF is also known as dipole to induced dipole interaction. So to summarize, London dispersion force happens when one molecule with a temporary dipole exerts a weak attractive force on another molecule. Remember, ang LDF ba ang weakest among the four types of intermolecular forces of attraction. And since it is caused by polarization, the strength of the force depends on the number of electrons present. So if if mas dagan ang electron, mas stronger ang intermolecular forces of attraction. Okay, so let's proceed to the second one. We have the dipole-dipole interaction. It occurs between partially positive and partially negative ends. So, if you could connect it to LDF, medyo pari-pariha lang sila, no? But always remember, basta gani LDF, it's a result of polarization. Okay, so this interaction is observed in polar covalent molecules. Take note, basta gani polar covalent molecules kay it involves the sharing of electrons. So these are common among amino acids wherein the electrons are shared both by oxygen and carbon atoms. If you could remember, amino acids, these are the building blocks of proteins. So, however, due to the electronegativity of the oxygen atom, it assumes a partially negative charge, whereas the carbon atom assumes a partially positive charge. So moreover, an increase in temperature diminishes. When you say diminishes, it decreases the strength of a dipole-dipole interaction. So dakong factor si temperature sa intermolecular forces of attraction, which may explain the observed volatility of certain polar covalent compounds such as sulfur dioxide. So class, when you say volatility, manggod, it's the tendency of a compound nga mas dali siya ma-diffuse sa air, or kibali mas dali siya ma-convert into vapor. Okay, so that's volatility. Okay, so we have an illustration here. We have carbon monoxide. So we have, of course, carbon monoxide is composed of one carbon and one oxygen. So if you could remember, no, nga kanang in this example, the oxygen molecule would assume the partially negative na region, sorry, partially negative. So the oxygen atom will assume the partially negative region, and then the carbon atom will assume the partially positive nga region. So if this carbon monoxide molecule is kanang bound to another carbon monoxide nga molecule, so this one right here. So partially negative ani nga molecule is attracted to the partially positive of the another carbon monoxide molecule. Okay? So ang tawag nga bond, we call that dipole-dipole forces. Or ang tawag nga interaction is called dipole-dipole forces. Now remember, basta gani in chemistry, opposites attract. A negative will always be attracted to a positively charged particle or atom or part of an atom, and yeah, vice versa. So dili pwede nga positive to positive or negative. Now, the third one, we call it the iron-dipole interaction. So, ang yung difference sa dipole-dipole interaction is it involves the, so kung you compare with dipole-dipole interaction, it involves ions. Okay, so ions can either be positively charged, we call them cations, and we have negatively charged, we call them anions. So, as an ion, it also involves a polar molecule. So, again, anion, negatively charged, cation, positively charged. So, we have an example here. We have sodium na ion, and it's bonded to water, okay? Na and water or H2O. Now, sodium here is a cation, kaya nga no, positively charged siya. So, asa man nakita ang ion-dipole force between sodium ion and water. So if you could remember, water has a partially negative portion which is found on the oxygen nga atom, and then it has partially positive nga region which is found on the hydrogen nga atoms. So since sodium is positively charged man siya, it's a cation, dito siya mas ma-attract kang oxygen nga atom, dili sa hydrogen nga atoms. Kay positive man ni sila, si oxygen kay partially negative. Now, ang tawag sa force na, that's what we call iron-dipole forces. Okay? So, we also have zinc and hydrogen gas. Okay? So, zinc is a cation, and then in a hydrogen gas na ay isa ka atom that assumes the partially negative na portion, and then the other one assumes the partially positive na portion. So, kung asa na-attract si cation nga zinc, dito siya ka partially negative na region sa H2 na molecule. So, ang tawag na sa force between them is iron-dipole forces. Okay? So, we have another example, chlorine ion. So, i-compare mo kang sodium mo kang zinc, si chlorine is actually an ion. So, it's negatively charged ion. And its interaction with water. So, since it's negatively charged, dito siya mas ma-attract sa mga hydrogen atoms sa water because, again, ang hydrogen atoms nakadiya ang mga partially positive na region niya. Okay? So, again, ion-dipole forces. So, the ion-dipole interaction is responsible for the formation of cations in a solution. Now, the last one, we have the hydrogen bond. It is a special kind of a dipole-dipole interaction which is formed when hydrogen bonds with fluorine, oxygen, and nitrogen. Actually, among the 4 bonds, ang hydrogen ang pinaka-strongest. Though if you could remember in your Chem 1, i-compare mo sa ionic, covalent, o hydrogen, i-compare mo si hydrogen bonds sa ionic o covalent bonds, ang hydrogen ang pinaka-weak. But if i-compare mo si hydrogen bond sa LDF, ion dipole to dipole-dipole interaction, ang hydrogen bonds ang pinaka-strong. Okay? So it's usually involved with fluorine, oxygen, and nitrogen. We actually call it FON. No, anong FON? Para mas dali nang siya ma-memorize. So say FON, we have fluorine, oxygen, and nitrogen. So anong kaning silang tulo? It's because they are actually they are one of the most electronegative elements in the periodic table of elements, atoms in the periodic table of elements. So the hydrogen atom is attracted to the partially negative and the fluorine, oxygen, and nitrogen. Because again, FON are one of the highly electronegative atoms in the periodic table. So for example, we have HF or hydrogen fluoride. Okay, so we have 2 molecules of hydrogen fluoride. This is one molecule right here, and this is another molecule right here. So, so fluorine would assume the partially negative na part sa molecule, and then si hydrogen will assume the partially positive na part. Okay, so kanisha this is partial. So kanisha this is partially negative. Okay, so of course si fluorine nga partially negative na region sa isa ka hydrogen fluoride nga molecule will be attracted to the partially positive region of another hydrogen fluoride molecule, which is ang hydrogen. Okay, so ang difference of course between that, we call them hydrogen bond. Okay, so that's hydrogen bond as an example of an intermolecular substitution. So the strength of the hydrogen bond is the reason for the high melting and boiling points of water. Remember, no, the co-op factor of intermolecular forces of attraction on why some states of matter have specific properties or exhibit specific properties. For example, in water, anong taas ang kuan? Melting point, anong taas o boiling point of water? Anong taas o boiling point si water? So, aside from water, we also have ammonia and alcohols like methanol. So, anong taas of boiling point si water? It's because, again, ang tawag sa bond that involve ka ng hydrogen, water molecules, we call it hydrogen bond. And take note, hydrogen bonds are the strongest i-compare mo sa other types of intermolecular forces of attraction. Because, again, the stronger the IMFA, the higher the required amount of energy to overcome these forces. Okay, so please remember that. Now, we have a flow diagram here. Actually, this is just an introduction. Okay, mubalik na po taani in the next proceeding lessons na ay another chapter na mubalik taani will be identifying the type of intermolecular forces of attraction that act upon these molecules. So, to give you a heads up, I'm giving you a copy of this diagram or illustration or flowchart. It's also in your lesson packet, so please study this. This will serve as a guide on how to identify intermolecular forces of attraction in a particular molecule. No? So just follow the arrow na ay mga questions, and then if it's a yes, you follow the arrow. If it's a no, you follow the arrow, and then it will lead to another question until such time na identify nimo kung unsa nga type of IMFA. So study this one. This will serve as a guide for you. Okay? So that's the end of week 1 lesson. I hope you were able to finish watching until the end of the video. So if you have questions, don't forget to jot them down on your notes, and then you can, or we can discuss it during our next sync classes, or you can just message me so that I could discuss to you the answers. But please do not chat or do not communicate with me beyond or before class hours or office hours, because I could guarantee you, madili ko motubag. So yes, so please consider that. Okay, so thank you so much, and I'll see you on the next one. Bye guys.